Hi, hello boys and girls. Today we are looking at chapter 6, the special lines and center in a triangle. Let us look at what is the meaning of angle bisector and also perpendicular bisector. Now first of all, an angle bisector is a straight line which bisects the angle. Okay, let us look at the picture here. OP is the angle bisector of angle MON. That means OP bisect these two angles, make these two angles into equal half. Then if OP is the angle bisector, one of the important conclusion is if we measure the distance here, PM and PN, where PM is perpendicular to OM and PN is also perpendicular to ON, these two distances, PM and PN, they are the same. This is the properties of the angle bisector. So let us look at one example. Now in the figure, if AD is the angle bisector of the angle BAC, then try to find X and Y, right? Just making use of the properties, these two distances, they should be the same, all right? So if they are the same, then it is quite easy for you to find X. And also, because AD is the angle bisector, that means these two angles, they are also the same. So you can also easily to find values of Y, all right? So you should try to calculate A and B, all right, for this part. And then let us turn to the other page. All right, this is the converse of the angle bisector's properties. Once we know that if PM equals to PN and where they are perpendicular to each other, then the conclusion is if we connect O and P, OP must be the angle bisector of this angle. All right? So let us look at one more example here. Now, if ABC is an isosceles triangle, that means AB equals to AC. And then we look at here, we have the two perpendicular distance, right? They are the same. So that means AQ must be the angle bisector of the angle BAC. All right? But the question asking us to find the angle ABQ. So if it is 48 degrees, because AQ is the angle bisector, we can easily know that it is also 48 degrees. And then this is an isosceles triangle. That means the two base angles, they are the same. All right, so making use of the angle sum of triangle, you can easily find the angle ABQ. Maybe you can look at the solution here. Afterwards, you can try number 2. And now, also look at one more definition of perpendicular bisector. Perpendicular bisector is a straight line, is a perpendicular line which bisects the line segment. That is the perpendicular bisector of the line segment AB. Because we have a line segment here, AB, right? We use a perpendicular line here. And then also bisect. The bisect means divided the line segment AB into two equal halves. AM equals to MB. So this straight line we call perpendicular bisector. And then one of our conclusion is, if this is the perpendicular bisector, then we measure the distance here. AP should be equals to BP. All right. So let us think about it. How can we come to this conclusion. Maybe we can discuss during the class, right? Example number 3, right? So if it is the perpendicular bisector, then these two straight lines, they are the same, all right? So we can easily find x here. And then after that, we also need to find the length of PQ. If we can find the value of x equals to 12, then after substitution, that length PM equals to 52. And then because PQ is the perpendicular bisector, and then this line segment MQ equals to 20 cm, right? And then just because it is a right angle triangle, we can easily apply Pythagoras theorem again to find the values or the length of PQ. All right? After looking at all these examples, maybe you can try to do 3.1. Try to solve it by yourself. All right? Work hard. Okay, that's the end of this video. Bye-bye.